Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 14 of JEE mains paper 2014. So let us start with question number 14. Students, let us solve question number 14 of 2016 JEE mains. Now the question is the temperature dependence of resistance of copper. Copper is a conductor and depends on temperature because its resistance depends on temperature, and undoped silicon, this is intrinsic semiconductor. Undoped is pure semiconductor silicon. Pure silicon is a semiconductor in the temperature range of this 300 to 400 Kelvin. It's best described by linear increase in. So when the temperature is increasing from 300 to suppose 400 Kelvin, then there will be increase in the resistance. What about the resistance? That you have to comment on the resistance. If the resistance increases for conductor, this is a theory. So for any conductor, as temperature increases, the collision, the vibration increases and the number of collisions becomes more frequent. Collisions of electrons with the ions increases and the free path decreases and relaxation time also decreases. The relaxation time decreases and we know that the resistivity, specific resistance of the conductor, is inversely proportional to relaxation time. As this decreases, this increases, so resistivity increases and therefore resistance will increase. So the resistance will increase in case of a conductor. So therefore here for copper, there is a increase in the, because the conductor, so there is a linear increase in the copper, increases with copper. And in case of this undoped silicon, which is intrinsic semiconductor, for semiconductor it is a reverse process. For semiconductor, as temperature increases, the resistance or resistivity will decrease and it becomes insulator at room temperature. So as the temperature increases, the resistance will decrease and that decrease is exponential. So this is the theory. You can see the textbook for the expression of exponential decrease and the resistance. So we have exponential decrease for silicon. Option number 3 is correct option. Okay, thank you.